Hello everyone, welcome to the Red Hat AI Day of Learning. So I'm Kai Xu, I'm the engineering manager and a senior principal research scientist of the AI Innovation team of Red Hat. So this session we will be talking about end-to-end model customization. While this is a very wide topic, I will try to provide you a concise guide on different aspects of what does it mean, and especially how you can connect your data to your models. So why do you need to connect your data to your model? Let's start with a particular scenario, saying that you're in a company and your company is trying to deploy an open source model that will help you review certain documents internally. This is a very typical use case in which data privacy or data security is important. Therefore, you have to looking for on-prem solution with open source models such that data will never leave you. Okay, so suppose in this case, the user start asking language model questions or helps. Hey, can you help me review this mergers and acquisitions agreement and flag any clauses that deviate from our standard template? Well, because this language model doesn't know your data, very likely it will say, hey, I cannot provide specific guidance, but I might give you like general review guidance. This actually is a good case in which at least the language model is honest about what it cannot do. But very likely, the language model will actually hallucinate or make something up. This is simply because the language model doesn't know the specific details of rules or standard template in your company. So what can the user do in this case? So let's step one step back on understanding why this even happened. As actually already repeatedly saying, this is rooted in the reason that those open source language models don't have your enterprise data. Or more importantly, they should not have your enterprise data because the large majority of those data remains public, and there's no way those open source language models is supposed to be trained on those private data. And if you happen to prompt or query a language model that managed to answer those questions, there might be a security leakage in your company that some data actually being used on the internet. All right. So with this context setup, I believe you understand the situation that a lot of data are not being seen by the model. Therefore, we need ways to actually provide those your own data into those models that you are trying to deploy. So this talk will focus on a journey on the basics you can do to the final or ultimate solution I would call that you can use to put in any data into the model you want. So I will start from the basics, from simple prompting techniques to a more advanced concept called context engineering, which is a smarter way to do prompting and putting the right information at the right time. Then I will spend most of the time talking about model customization through fine-tuning. And while this concept, again, is very wide, I will basically focus on how you can use synthetic data generation and supervised fine-tuning as two driving techniques that provide you a very robust and manageable solution to do this fine-tuning. Finally, I will discuss two use cases that this model customization through fine-tuning actually can help you. One is about how can you internalize certain skills such that your overall solution is more efficient. The second is how you can inject new knowledge into your model such that the overall solution is more accurate. All right, let's start with prompting. As for anyone have ever used a language model, there are basically some program that will take a list of prompts, a prompt, which is basically a list of tokens or text, and return your response. So to connect your data to your model, probably the simplest solution is to actually put in your missing enterprise knowledge as part of the prompt when you ask the language model question. As example, in this scenario I set up, you can basically say, hey, given these rules, blah, 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 please review this document for me. And hopefully with a language model that is able to follow instruction well, it will actually use the rules that you specify particular and give you a response according to them. And how to define this particular rules or this part of the prompt is actually not so straightforward task. And people refer this task to find the best prompt to solving a particular problem, either manually or automatically as prompt engineering, which is kind of an art, has been how to do that manually using human intuition, or an engineering task that how to set up a proper pipeline to do this. While prompting is straightforward and can be used as a starting point to connect data to a model, this approach can fall short in many aspects. The first case is when knowledge is literally too large to fit into the effective context window of the large language model that you are using, which is still the case for a lot of small to medium-sized models. This means your knowledge or the information you want to ask language model to refer to might live in like 1,000 pages of PDFs, and you can not simply putting them as part of the prompt anymore. So one solution is you might be able to manually summarize or using a large language model to distill those knowledge into concise prompts, but this is not always possible. And more fundamentally, this prompting usually more suits for a need where you are trying to find a prompt that will work for tons of queries. But in general, different queries might using different information from your enterprise data. So it not always be possible to find an all-in-one prompt. Or there are many other issues I won't be going through here. But with this being said, there's also a lot of problems that prompting is probably enough. And if for your particular use case, you manage prompt model to satisfy your need, I think you can also stop here. All right. So as I said, for complex queries that you cannot actually solve this problem simply through prompting, what people start doing is something called context engineering, where in addition to the prompt and the model or as a core, you build an external system around the whole your language model and trying to let the whole thing fetch the right context at the right time. A popular or probably the most well-known solution is called RAG, Retrieval Augmented Generation, in which you put useful knowledge into a vector database, and for each query, what you will do is you will try to fetch the right information from this external system and put them into your prompt. With this, it kind of solves multiple issues I mentioned above. For example, as long as the vector database can store all your large knowledge and you are managed to retrieve them at the right time and put them back, you are no longer limited to the size of the knowledge, and the knowledge being used will also depend on your query. Another popular solution, or where the term context engineering emerges from those agentic coding systems like Cloud Code or Codex. So instead of building a RAG setup where a vector database and a particular retrieval model is kind of hard-coded in the pipeline, those systems mostly rely on the language model itself to actually using tools to interact with the external system and getting the right context at when it's needed. For example, very often Cloud Code will simply check what files exist in the current directory and what content they have, and using them as a context to decide what to do next. While this is, again, another effective solution that you can put in data into the model, those approaches also have their own limitations. For RAG in particular, how you put the information or your knowledge into those databases is basically through chunking your document, basically breaking the whole document into smaller pieces. And for each piece, you will use an embedding model to kind of create an embedding for them such that they can be retrieved later. And the overall performance of such system is very heavily dependent on how you chunk those your raw document, as well as how good this retriever is doing on finding the right piece of information for the query. And there are two cases that this can fail. One is there might be some information that is needed and this retriever cannot find, which is it's a failure of the retriever itself. Another case is that if the chunking is too large, and the retriever managed to find the right chunk, but the chunk also contains some misleading or irrelevant information, the language model can often be confused when such chunk is if such external knowledge is provided on answering the questions. So for the agentic kind of systems, while in theory, if the large language model is good enough, this type of solution seems to be very general purpose. But in fact, their actual performance very heavily rely on how well the language model is understanding the particular domain you are working with. For example, if for people have ever used Cloud Code, the model that can work with that system is still heavily only the few models that as Anthropic or OpenAI have developed it, and the reason is because only those models understand the concept of software engineering so well, as well as knows how to interact with a particular system. Again, as I said, this is a kind of increasing journey that you find problem, and if it cannot solve a problem, you move to the next stage. And a lot of cases, these techniques might also be enough for a particular use case. While this being said, for this particular context engineering concept that the model need to working with external system, the actual performance, as I elaborated here, is very heavily dependent on how good this underlying model is. And you can actually turn a case that the overall system doesn't work through improving the model to something workable, or even keep improving the performance. Well, this brings us to the focus of this session on how can you actually fine-tune this language model through fine-tuning. Well, I've been kind of briefly mentioned in the agenda that I refer training or fine-tuning as the ultimate technique you can fix language models. The reason being that is technically with the right data and the right training techniques, you can almost introduce any wanted behavior or put any knowledge into this model. However, this procedure is not so well established, or there's no one solution that will fit all needs. Companies like Anthropic or OpenAI, they have their whole entire research team and engineers trying to figure out how to keep improving those models. But lucky enough, there is some approaches that is more well established that is prescribed enough to solving a wide range of problems, which are using a combination of instruction data and supervised fine-tuning. So instruction data basically means textual data that are pairs of user query and model responses. And they can use as a supervision to teach a model, hey, if you receive this particular user query and this particular language, you should give this particular language model response or something similar. And supervised fine-tuning is a family of algorithms that can teach language model using to learn those expected behavior through instruction data. So the two big questions here is, where are those data come from? And second is, if I learn a new knowledge or skill, would I be able to still maintain what I have previously learned? A side note here is that this particular direction of fine-tuning is not meant to be replacing any external system. As I mentioned, it's a technique to further improve or making the whole system more efficient. So it actually works with all previous techniques we have been discussing so far. All right, let's discuss where those data comes from. As mentioned, instruction data means pairs of user queries and language model responses. In a classic setup, those data are usually collected by human, and they are not, the numbers of the samples are very limited and very expensive to further expand. Companies like Scale AI basically build a business on how to crowdsource or hire contracts to collect more data like this. And it can be even more challenging when you want to collect such data for your particular domain. So the solution to this, what we are highlighting here, is something called synthetic data generation. It's basically a family of techniques that allows you to amplify your existing data. There are two examples here I'm putting. One is what I call skill data. So as I said, instruction data basically pairs for user query and language model responses. It's probably not hard to annotate, say, 5 to 10 examples of such data, although it will be much more expensive to get in like thousands of 10,000 of such data. However, SDG is such a technique that if I provide you a few demonstrations, it will use a set of pipeline and data transformation that convert 5 to 10 examples to 5 to 10,000 examples, which is enough to train a language model. The second recipe of SDG is what I call knowledge data, which again, if you have your company's internal document, what you need is those documents plus a few examples of what type of questions you want the language model to answer from those documents. What SDG will do is then to go through your document, read it line by line, and trying to find similar questions that those documents can be answered, and not only find those questions, as well as based on a document, extract the corresponding answers and using them to create this instruction data that one can use to fine-tune a language model. So in short, SDG basically converts manageable human inputs, which is small scale and can be done by a small team, into a large scale instruction data that can be used to effectively fine-tune large language models. So our team here also maintains and develops this upstream open source library of SDG Hub that basically provides a bunch of predefined recipes that you can reuse. And this framework itself is very flexible, such that you can easily tweak or expand those recipes to suit your own need. Feel free to check it out and raise issues on our GitHub. So now, suppose we have this instruction data synthesized through SDG. The next phase for us to do is actually do supervised fine-tuning to make our language model learn from this data. So you might heard multiple terms that representing this same process as a supervised fine-tuning, or more another frequently used term is instruction tuning. So they basically refer to the same thing, while instruction tuning is kind of having a slightly focus on to distinguish multiple training phases of any instruct model you might download from the internet. Usually those models first go through a pre-training phase, then instruction tuning phase, then preference tuning phase. And they are using different types of data and the learning techniques. Therefore, instruction tuning is more often used in context to distinguish which phase this model is currently going through. So, as I mentioned, like learning new data is actually not that hard, but what is really hard and needed is how to maintain previously learned the knowledge or skill while learning new data. So a typical case, or if you apply a very simple supervised fine-tuning technique to learn new data for a large language model, something called catastrophic forgetting will happen. It basically means the model, while it learns this new data, it's forgetting all previous skill or knowledge that you might be interested in. That could be simple or important skills like its ability to follow instruction, or important knowledge that actually useful to answer your queries as like common sense knowledge. So there are two big directions that people have been using to address this catastrophic forgetting issue. One is called the use of replay buffer, which basically means when I learn something new, let's also put something old in this new learning phase such that it didn't forget. And the research community has found that, interestingly, you don't really need the whole big data set from your previous phase. You only need a core subset of data from your previous, which is enough to make sure the model didn't forget stuff it learned previously. And in a case that you want to learn both skills and knowledge, what we have been advising is using a multi-phase supervised fine-tuning approach, in which you first learn knowledge, and then when you learn when you next phase learn the skills, you put some part of your knowledge data as well as some skill data from the model you obtained in the beginning, and put them together when you do the final fine-tuning phase. However, this approach, as I said, requires the data of the model you obtained, and it's not generally accessible for any language model you download from the internet. So another approach that is more flexible and allows you to use a larger family of instruction model you download from the internet is called Continual Learning. And we have been working on this particular algorithm called orthogonal subspace fine-tuning, OSFT, which is an algorithm that will smartly only fine-tune a subset of the model weights. The concept here is that deep learning models, or which includes large language models, they are something called over-parameterized, meaning that they actually have more parameters that is needed to solve a particular task. And for any language model you download online, although it might be 17B or larger, a lot of parameters there are not effectively used. What OSFT effectively doing is it will first find those parameters that are not effectively used, and when you're learning new knowledge or new skill, only fine-tune those subspace, and this allows you to learn new knowledge without catastrophicating. This algorithm is accessible from this open source library we've been working on called Training Hub. And again, feel free to give it a try and file issues on GitHub. All right, with SDG and introduction to SDG and supervised fine-tuning introduced, I want to discuss two specific use cases that you can use them as a combination to solve. So the first case is what I use called internalizing customer skills for better efficiency. So suppose you successfully prompt engineer a Llama 70B model, which is quite large, but you want a smaller model to do the same task so that you can save a lot of cost. So what you can do here is through SDG, you can provide a handful of demonstrations and use that particular Llama 70B model as a teaching model to generate thousands of data samples, which is large enough to fine-tune a small large language model. Then you can use some supervised fine-tuning technique, either it's SFT or SFT, to actually teach this smaller model to learn this new skill. And the choice of SFT or OSFT here is flexible in the sense that if the only use case for the smaller model you want to do is in this particular task, SFT might be enough. But in a lot of cases, some common sense knowledge, as I discussed, is usually useful to even answer domain-specific queries. So what I would recommend is still perform OSFT as long as their performance is on par on this particular training set. So with this two stage, you will effectively convert a Llama 70B model with a very long prompt into a Llama 8B model with a very short prompt. And through some simple estimation, this cost can be as large as 90% reduction. And because you are using a much smaller model, the latency will also have a huge reduction here. All right. So the next use case I want to dive into is called injecting new knowledge for improved accuracy, which is a very common use case for large language models deployed to RAG systems. So again, you have successfully deployed a RAG system around your local language model, but you have put your enterprise data into the RAG system, but overall the RAG performance is not as good as you want. So what you can do, apart from tweaking the RAG system itself, is to actually making the language model know your domain better, so it will naturally be better at understanding or answering questions in this particular domain. So as a recipe, what you can do is through SDG, what you can do is collect a bunch of internal documents that could be those documents that you basically use to build your RAG vector database in your RAG. You can pre-process those documents through docking, so they are converted into a format that SDG can understand, and use SDG to generate a large number of data samples that representing potential question and answers that someone would be interested in from those internal documents and ask the language model to learn them. Then what you will be doing next is training. You can effectively using this OSFT to perform continual learning such that this language model learns this new data while still being good at doing this particular RAG skill. So with this two step, you will effectively convert the RAG with untrained language model with a RAG with a language model that knows your data very well. And we've been seeing accuracy improvement on this particular setup being more than 10% of accuracy. This is actually very expected in the sense that a lot of questions relies on kind of a general knowledge on the domain that might not be existing in a particular chunk, or it actually rely on multiple chunks to understand a particular complex queries. All right, let me wrap up my learning session on topics that actually I didn't cover today. As I said, model customization is a very large topic and the land scope is huge. So from something more close to what I discussed in this learning session, there are actually more combinations of synthetic data generation plus supervised fine-tuning one can perform to achieve certain behavior of the large language model. For example, you can apply annotation pipeline from SDG trying to convert a large language model basically into a classifier suiting your need as well. And there are all kinds of different combinations you can achieve. And another interesting thread is other training method. I'm mostly focusing on supervised fine-tuning in this session, but you can also another type of training technique is called preference tuning, which will allow you to change the default behavior of your language model. Like when something is under-specified, the language model, for example, might choose to respond a long response or more detailed response, and preference tuning is a technique to actually control this default behavior. Or you can use reinforcement learning that allows your language model to learn either from the environment, meaning the external system in a lot of those deployment, or actually from human feedback. And as field emerge into the agentic world, where language model have more of their own ability to interact with the system or doing tool calling and stuff, they are more of a model customization concept than like kind of converge to agentic or agent customization, where trying to put this concept in a larger scope, like how do you automatically optimize your prompt? How does this model manage external memory when it work as an agent? And how do you do something called inference time scaling, which allows the model to smartly spend more computation while it making decisions at an agentic flow. All right. I think that's my learning session, and thank you very much. And questions are very welcome. Thank you.